In Part 2, we looked at sustainable systems. Now in Part 3, we're going to look at recyclable materials. Recyclable materials are critical to recycling everything. And to have recyclable materials, we have to back up all the way to the molecules. Currently, materials are created with no thought of how they could be recycled. And so manufacturers churn out products by the millions that can only be destined for landfills. Recycling is at best an afterthought. And yet, if materials can be engineered to be recyclable, they could be brought back into production to be used in new generations of products. Let's take a look at materials science. There are some truly amazing things that are going on in the world of materials science. There are such things as polymers that mend themselves. There's also two-dimensional graphene, which is essentially a sheet of graphene that is only one atom thick. There are such things as artificial diamonds and rubies, and materials that are capable of morphing into different shapes. But even more amazing than that are quantum dots. Quantum dots are essentially artificial atoms. They can simulate the properties of any element on the periodic table by attracting and releasing additional electrons. And the concept of hacking matter was written about in a novel by Will McCarthy. There's even a kind of thing called programmable matter, and these are materials that can be programmed on the molecular level to do a wide range of things, such as process data, transform to another material, change from one pre-programmed shape to another, among other things. It seems as though there's really no limit to what could be done in materials science. And so the question is, if science can create materials like these, why can't they create recyclable materials? They probably can. And what exactly do we mean by a recyclable material? It's a material that is capable of being transformed from solid to non-solid and back to solid. And in addition to that, we want recyclable materials to generate no waste, to be free of any need for additives, to be perpetually recyclable, and to be usable for the same or similar purpose. And so we're going to look to materials science to create recyclable materials. So how do we get materials scientists to create recyclable materials? Actually, it's pretty simple and really no different from asking them to create any material. It's done through requirements. Let's take a look at this example. Let's say that we have a need for a hard plastic to serve as a housing for laptops, TVs, stereos, and that sort of thing. So basically, the way it works is that the product designer has requirements for this particular material. And the requirements are such things as that the material be durable, that it be washable, wear-resistant, black, and here we go, 100% recyclable. So it's possible to make 100% recyclability a requirement for a new material. So what we just saw was a set of requirements that was passed from product design to material engineering. Now, because these materials are to be 100% recyclable, the materials engineers must design a plan for reprocessing these materials in parallel to their development of the materials themselves. So in other words, when the material is designed and created, the process for reprocessing it also has to be designed at the same time. The reprocessing plan is, in effect, what guarantees the recyclability of the material. The materials, the reprocessing plans, and the third thing, the facilities and equipment needed to do the reprocessing all have to be coordinated among each other to ensure that the materials can be recycled. So now, why is it important to have recyclable materials? Well, let's take another look at the system for material sustainability. Here again is our simplified version of the system. So let me explain what happens. Used products that no longer function go through a disassembly step. We're going to talk about disassembly in more depth later in this presentation. So once the parts are disassembled, they go to the materials processor. Now remember, these disassembled parts are made of recyclable materials. At the material processor, they are separated, and each type may have its own reprocessing method. Then the materials are reprocessed and made into new supplies. And then the reprocessed materials go back into production. This is why recyclable materials and reprocessing plans are so important. And really, without them, recycling everything is impossible. There's a lot more detail about this in the book. Methods of reprocessing include such things as catalysts, temperature change, which can include melting, freezing, electromagnetism, which can include microwaves and other sorts of waves, and mechanical reprocessing, such as shredding. And as a matter of fact, I have an interesting example of shredding. This is an interesting company from Switzerland called Result Technology. They reprocess such things as circuit boards, electric cables, aluminum alloys, electronic scrap, and compound foils. And here's essentially how they do it. And this is something that has bothered me a lot in the past. I wondered how we would recycle such a thing as a circuit board, but basically what they do is they feed these into a shredder, which also spins the shredded material so as to cause it to separate. And then the separated materials result in such things as copper, aluminum, and plastic. And so it's a very exciting process just to think that you could take something like a circuit board and simply shred it and recover all these materials. Of course, I just have this one little question, which is how much is left over as waste? But this is an exciting technology and so simple. So we've just covered recyclable materials, in which we talked about the need for recyclable materials, how they can be created, and how they can be reprocessed. And in the next section, which is going to be part 4, we're going to cover design for disassembly, and actually we'll wrap up with new mindset and people as well.